Solving the evil second-degree equations, completing the square, or factoring the unfactorable. Okay, they're not really unfactorable. So we're going to be looking at the condition when a is equal to 1. Okay, so here's our a term, and it's 1, our b term is 6, and our c term is 2. Now, when a is equal to 1, it's really quite simple. What we want to do is we want to turn this into a perfect square trinomial. Okay, and so since 2 is not a perfect, like you see x squared is a perfect square, so your first term is a perfect square, but your last term is not. So we're just going to get rid of that last term. So I'm just going to subtract it out of there. So I'll subtract the last term from both sides of the equation. So I subtract 2 from this side, it's gone. Subtract 2 from the right-hand side, and we have minus 2. So you're left with x squared plus 6x equals negative 2. Now remember, in a perfect square trinomial, we're always looking like, is the first term a perfect square? Is the last term a perfect square? Is the middle term 2 times the first times the last, or the square root of the first times the last? Okay, so what we want to do, since the first term is 1, to get the last term, all we have to do is divide this middle term by 2 and then square it, and there you go. So I'm going to divide the middle term by 2 and then square it, and I'm going to add that to both sides. Okay, I'm adding it to this side to make a perfect square trinomial, but if you add something to the left-hand side of an equation, you also have to add it to the right-hand side just to keep everything balanced. So 6 divided by 2, that's 3. I'm going to square that, 9. And I'm going to add that to both sides. So we have x squared plus 6x plus 9 is equal to negative 2 plus 9. Okay, the negative 2 plus 9 is, of course, 7. All right, so what we're left with is a perfect square trinomial, okay? And we get a perfect square trinomial on one side of the equation, and on the other side we get a nice constant. Okay, so in this case I have x squared plus 6x plus 9 is equal to 7. All right, so since it's perfect square trinomial, I'm going to take the square root of the first term, square root of the last term, okay? And then, you can always double check, just make sure that, first times the last times 2, is it your middle term? And it is, so there you go. So you put your square equals to what the right-hand side is, which is 7. Okay, so now to solve this, I'm going to take the square root of both sides, and we don't forget to put your plus minus when you take the square root. So we have x plus 3 is equal to the plus minus positive negative square root of 7. And now 7 is not a perfect square, so we're going to leave it as plus minus the square root of 7. And then to get the x alone, I'm going to subtract 3. Okay, so isolate your variable. So x is equal to negative 3 plus or minus the square root of 7. And that's your answer. Okay, so your x1 is going to be negative 3 minus the square root of 7, and your x2 is negative 3 plus the square root of 7. Okay, let's look at another example. So completing the square when a is equal to 1. So here we have x squared plus 4x plus 5 is equal to 0. And once again, I want to get rid of that 5, so I'm going to subtract the last term from both sides. So subtract 5 from the left-hand side and subtract 5 from the right-hand side, and there we go. We have x squared plus 4x is equal to negative 5. Okay, now what I'm going to do is I'm going to divide the 4x by 2. So divide the middle term by 2 and then square it, and then add that to both sides. Okay, so we're going to get 4 divided by 2 is 2, square it, 4, and we're going to add 4 to both sides. So we have x squared plus 4x plus 4, okay, is equal to negative 5 plus 1. And so that is going to, unfortunately, give me negative 1 on the right-hand side. Okay, so you're left with a perfect square trinomial on the left-hand side and a constant on the other side. So we end up with x plus 2 is equal to negative 1. Okay, looks fine, except for when you go to take the square root of both sides. I can't take the square root of negative 1. It just isn't done in polite company. Okay, so no, we can't do anything about that. Okay, so it's unfactorable. This is totally unfactorable. Okay, not just, something we're calling unfactorable. So it just doesn't factor. Okay. All right, let's look at another example. So here's x squared plus 2x minus 5 is equal to 0. So I'm going to subtract the last term from both sides of the equation, and I get x squared plus 2x is equal to 5. And then I'm going to, to make it into a perfect square trinomial, I'm going to divide this 2x. I'm going to take the b term, divide it by 2, okay, and then square it, and then add that to both sides. So that gives me 1. Square it is 1. Add it to both sides. So I'm going to get x squared plus 2x plus 1. And then add it to the other side. So I have 5 plus 1. It's going to be 6. So we get a nice perfect square trinomial on this side and a constant on the other side. So perfect square trinomial, I'm going to take the square root of the first term, which is x, square root of the last term, which is 1, and make sure that the x times 1 times 2 is 2x. All right, is equal to 6. So there we go. Take the square root of both sides. Don't forget the plus minus thing in front of our square root of the 6. And that gives us x plus 1 is equal to plus negative the square root of 6. All right, and then to get rid of the 1, I'm going to subtract 1 from both sides. So x is equal to negative 1 plus or minus the square root of 6. Okay? And that's it. If the square root of 6, if it was a perfect square, we could totally simplify this and get to, an x1 and an x2. But there you go. There's your answer.